Hello guys, welcome back. In today's lecture, we'll be talking about another most commonly used programming patterns, which is multiple pointers pattern. Okay, so what is multiple pointers patterns? Let's see the definition first, and then we will understand about the concept, like how it works. Okay, and why we use it. So let me quickly stretch it a little bit, and let's zoom it. I think this much zoom is enough for you guys, right? You guys can see this. Okay, so the idea of the multiple pointer pattern resolves the solely around the creating identifiers or pointers that correspond to an index or position, okay, which moves towards a specific direction based on a certain condition. Okay, so the pattern is quite efficient for solving problems with minimal space complexity. Okay, and it's very efficient for solving problems. Okay, I don't know why I wrote this twice, so let's remove it. Okay, yeah, so now let's understand like what is this, what is this definition. Okay, so let's say you have a huge array. Okay, in that you want to find some sort of numbers. Okay, so with a no, like without knowing any pattern, how you will solve it? Let's say you want to find the sum of two numbers. How you will find it? You will simply run two nested for loops, right? You run a for loop, and inside that for loop you will run another for loop, right, to find basically array at position I, array at position j. If those two number matches, then you return it. Okay, so this way you will solve it, and this way you will get the time complexity of O of n square very easily, right? Because you are running two for loops, that too you are running in nested fashion, right? So that is why this multiple pointers pattern was introduced. Okay, so in this what we do, like we create pointers. Okay, so most of the people call it two pointers as well. And why they call it two pointers? Because it's simple, right? Most of the beginners get confused in these two terms, like multiple pointers is different and two pointers is different. See, if you are using two variables as the pointers, okay, then it is two pointers. If you are using more than two variables as the pointers, then it is multiple pointers, bro. There's nothing much to think about it. Okay, now let's understand a little bit more about multiple pointers pattern. Okay, so I actually have this board here, and I prepared us some sort of array here as well. So you can consider this as a sorted array. Okay, so 0 1 2 3 4 5, so we have 5 elements, right? So you can consider it as a sorted array. So let's say you want to find the sum of two numbers. Okay, let it be 0, let it be 1, or let it be anything. Okay, so what you can do, you can simply put a variable as a pointer to the first element, and you can put another variable as a pointer to the last element. Okay, and if you can compare, like if this number and this number are summing together as 0 or whatever number you pass, then you return those numbers. Otherwise you move this number here, and then you find this number and this number are giving me the sum. If it doesn't, then you move this number, this pointer here. Okay, so this way we move the pointers one by one towards each other, and they can be in any direction, not towards each other always. Okay, so see, I've shown you an example, like we can set the pointers like this, right? And you can consider these pointers as the variables. Okay, you can define these variables as let start equals to array at position 0, end equals to array at position length, array at position length minus 1. Okay, so these will be the variables which will hold the start and end index. Okay, and then like other way you can do is, like you can store these two pointers like together here. Okay, one after another, and then you can move these parallelly. If you find the sum here, then like return it. If you doesn't, then move this one here, and then compare these two numbers. If you doesn't find the sum, move this one here, check this again. If doesn't, then move this one here. Okay, and then compare. So this way you can basically iterate through the array in way more efficient way, because you have two pointers, right? Two variables which are checking your array. Okay, and multiple pointers, let's talk about multiple pointers. In multiple pointers, nothing much is there. You simply need to add one more pointer, right? So in case your like question requires more than 2 pointers to solve it, okay, so you can create another pointer, you can store it in between or along with this one, along with the starting index. You can state it as middle index or the second start index and then end index. Okay, so basically the idea is you have to create the pointers, okay, which you have to store in some particular index, and then you have to move in either direction. It can be from starting to end, it can be from end to starting, and it can be from middle to left, middle to right. Okay, so this way we basically create the pointers to check whether the whether you are getting the desired result from that array or not. Okay, and there is one more thing to keep in mind. This like multiple pointers only works with the sorted arrays, right? So if you have unsorted array, then you will find hard times to solve that thing with the like multiple pointers pattern. Okay, so yeah, this is how we used to solve the question or array, or we can say our problem statement with the help of multiple pointers. If in case we have to find a pair, or if we have to find the unique values from an array which contains duplicate numbers, okay, and those sort of things. So now let's look at an example. Okay, so I have a question here. These are most commonly used questions. Okay, let me quickly increase the brightness because I myself is not able to see it. Okay, so yeah, we have a question which says like write a function called find zero sum. Okay, which accepts a sorted array of integers. Okay, so you basically have to create a function which accepts a sorted array. So far so good. Okay, now find the first pair of the integers where the sum is 0 and return them in the subarray. Okay, so what basically you have to do, you have to find the pair of the numbers which contains whose sum is 0. So here if you see, I have passed an array, right? It is sorted array only. Okay, so here what I have to do, see, this -4 and this +4, they are summing up to 0, right? So what I have to do, I simply have to create a subarray, and there I have to pass those two numbers. Okay, now if the pair does not exist, return the empty array. So in case if you are looping through the array, and if you doesn't found any pair which is summing up to 0, then in that case you have to return the empty array. Okay, so as you can see here, we don't have any such pair which is giving us 0. Okay, here also we don't have any such number which is giving us 0. Okay, and don't consider this 0 because we are talking about pairs, like the two numbers sum should be 0. Okay, yeah, so how we can solve it with the naive approach, okay, without knowing any pattern, without any blueprints. So let's see. So here is a naive solution. Okay, so in this one what we are doing, we are running a for loop, we are accepting an array. Okay, and we are considering that this is a sorted array, right? And if it isn't a sorted array, if like your interviewer asks you to basically pass an unsorted array, then you simply pass a sort function here, right? Sort it first and then solve it. Or this you have to do if the input array is not sorted. Okay, so you have to do sorting in case if the array you are getting is not sorted, but in our case we have to consider it as sorted. Okay, so we are running a for loop, right? And inside this for loop we are running another for loop which is starting from the like +1 index from the current index of I. Okay, so basically it will be something like this. So first I is here and j is here. Okay, just forget about this, I'll delete this. Okay, so this is how it is going to start. Okay, and then it will loop through the array, right? And you guys already know like how the for loop works, right? So this for loop will loop through the array, and then inside of that loop this loop will run, right? And there are so many works, like so many things going on, like it will loop so many times. So that is why the complexity will be O of n square, and by now you already know like why it is O of n square, right? So because we have the nested for loop, and here if you find the sum, like if the array at position I and array at position j sums up to 0, okay, then you have to return them in the sub array. Otherwise, what you have to do, you have to return empty array at the end. Okay, so let's see. Let me just rename it naive. Okay, naive find zero sum. Okay, so now let's run it and then let's see like how it works. So here let's pass any of these example. This one let's pass. So it should return -4 plus 4, right? And I think I have to zoom it. Okay, add a little bit more so you guys can see clearly. Okay, so yeah, so I have passed this array which contains the sorted integers, and as you can see, the first and the last element itself is returning this -4 and +4, so it doesn't have to loop much, I think. Okay, it basically, the nested for loop, like this naive solution, have to loop through the array. Okay, it doesn't have any other option. So here we are getting -4 plus 4. Now let's see another example. Find zero sum. Let's pass this array. Okay, so I'll just clear it. Yeah, so now as you can see, this array doesn't have any pair which is giving me 0, right? So what we have to do, we simply have to return empty array at the end. Okay, now the other one here, by seeing itself, we can say like it doesn't have any pair, but still we'll pass it in our function to see whether the function is working or not. Okay, so now let's parse it here. Okay, and then as you can see, this is also giving us empty array, right? So now let's try to do a little bit of work. Let's say we have this array, right, which is giving us empty array. So let me try to add 1 here. So right now we have a pair which gives us 0, right? -1 plus 1. So as you can see, it is giving us 0. Sorry, it is giving us that pair, right? So that means our function is working fine. But since it have two nested for loops, so it is not that much optimal, right? Now let's look at the refactored version of it, or let's look at the so-called two pointers, multiple pointers pattern version of this problem statement. Okay, so here, like by seeing already, you guys can like identify why it is called multiple pointers. Okay, so as I have told you, like we will create two pointers, right? This is one pointer. Basically, these are variables which we use to create. Okay, so one will hold the index of 0. Basically, one will hold the position 0. Okay, so you can say this one. Okay, and the right one will hold the index of -1. Okay, length -1. That means it will be the last index. So this is our sorted array. One pointer we are storing here, one pointer we are storing here. Okay, now what will happen? We will loop through this array if the left element is smaller than right element. So right now we have this array. Where is it? One second. So we have this array. Okay, so this left element is -4 and right element is +4. So obviously this one is smaller than this one, right? So we are going to loop through the array only when the left element is smaller than right element. Okay, and then first we will check if the left plus right gives us sum equals to 0. If it does, if it gives sum like which is equals to 0, then right away we will return that in an subarray. Okay, otherwise what we will do, if the sum is smaller than 0, that means sum is in negative. Okay, so in that case what we will do, we will move the left element towards the right element. Okay, like this. And if the sum is greater than 0, okay, so in that case what we will do, we will simply move the right elements towards the left element. Okay, so that is the simple idea. Let me quickly shrink it a little bit so you guys can see the code and the logic parallelly. Okay, so this way it will work, right? Okay, so this much is, I think, fine, right? So this way it will work. And then if still you doesn't find any element like which is giving us sum up to 0, then we will simply return empty array. Okay, so here the time complexity will be O of n. I don't know why I wrote O of n square. Okay, space complexity will be O of 1 always, because we are only going to return two elements, maximum two elements only, right? Or least we are going to return the empty array. So the space complexity will be constant only, because we are going to return only constant values, right? So now let's run this find zero sum to see how it goes. Okay, we will use the same examples as the naive solutions. Okay, so we will just rename it, or I think find zero sum is fine. Okay, yeah. So as you can see, this one is also giving us -4 plus 4. Okay, and then we can use another one. So this one was giving us -1 plus 1. Let's remove this so that we can run this function. And as you can see, find zero sum, this one is also giving us -1 plus 1. That means it is able to find the pair and it is able to return it. Okay, so now let's break the pair. Let's remove 1. Okay, let's see what happens. So now it is giving us empty array, right? So that means it is unable to find any pair in it, and then it returned empty array. Okay, so this is how like you can make use of multiple pointers or two pointers, so called, because right now we are using just two pointers, left and right, so you can call it two pointers, right? And if there is like pointers more than two, then you can call it multiple pointers, right? So it's nothing that much complicated. It was quite simple. Okay, and as you can see, this is just one loop, right? And in comparison to this naive approach where we are running two nested for loops, right? So that is why this one is like way more costly than this one, right? This one is just O of n. It is just running n number of times. Okay, if the size of array is n. Okay, so that is why it is way more efficient than this one. Okay, that is why we have the like problem solving patterns, right? So we have a pattern, we can make use of it, we can change it according to our problem statement. Okay, so that is why we call it I'll repeat it again, that's why we call it the blueprints which we use to solve our problems. Okay, not our personal problems, our programming problems, right? Yeah. So and I've seen like one more question. I think it was somewhere in the some of the like competitive coding portals, like where an interviewer have asked, like he have asked almost similar question, but he have twisted it a little bit. And how he have twisted it, like let's say here we are finding a sum of 0, right? We are picking two numbers and we are checking if their sum is 0 or not. Okay, what that question was saying, like you have to pass a number here. Okay, instead of passing the array only, you have to pass a number here. Let's say I have to pass 3. Okay, so in the array you have to find two pairs who are summing up to 3. Okay, and then you have solved this question where you are finding a sum to 0, and then if you are a beginner you will quickly get confused, right? Like how I'm going to solve this. So let me show you this one as well quickly. Okay, so let's consider you have to find a number, you have to find a sum uh, which is equivalent to the number which you have passed here. Okay, so sum. Okay, so in the same example I'll change it. Okay, so what I will do, I'll simply replace all the places wherever I have used 0. Okay, so is it tricky? The answer is no. It's just a presence of mind. Okay, you just have to think, you just have to be mentally available that point of time. Okay, see, now if I run it, let me show you. I'll use that same naive function. So here let's say let's pick minus 5 minus 4, like 5 minus 3. 5 minus 3 will give us 2, right? So let's pass 2 here. Let's see if it gives minus 3 and 5 or not. Okay, let's pass 2. So as you can see, it is the same function. I just did the small modification and it started giving me the expected result, right? So here you can pass any sum, any number of sum. If the pair matches that sum, then it will return that pair. Okay, otherwise it will return empty array. Okay, so let me show you another example. Let's say I want to find the pair whose sum is 12. Okay, so there is no such number which is written, which can sum up to 12, so it will give us empty array. Okay, so let's try another time. Let me just quickly clear it. So let's see this time, like -1 plus 1 will give us 0, 2 minus 4. Okay, minus 4, 2, let's use this one then, minus 2. Okay, so here I have passed -2, so I want a pair whose sum is -2. So as you can see, our code gave us the pair, like -4 plus 2 will give us -2, obviously, right? So this is how we can basically change the this is how the interviewers twist the question a little bit, because this is most commonly asked problem, right? Find pair of numbers who sum up to 0. Okay, this is most commonly asked question. So what interviewers do is, like, they twist that question a little bit. Okay, and then because of the interview pressure, and because of, like, you are being beginner, or because you are in stress that time, you don't like, you face a hard time to figure out like how I'm going to solve it. Okay, so this was the naive approach. Let me show you the same thing with the this one, optimized approach. Okay, so here we have passed an array, and then here I'll pass sum. Okay, so wherever I have used 0, then, okay, so num sum I'll use. Okay, because the sum I have already used here. So what I will do, I'll simply replace it with wherever I have used 0. Okay, if these two elements sum up to the sum number which I have passed, okay, if this is the thing, then return those two elements. Otherwise, if the sum is smaller than the sum which I have passed, then like, move from the left side. If it is greater than the sum which I have passed, move from the right side. Okay, otherwise, if you didn't find any sum, if you didn't find any pair, then at the end return empty array. Okay, now let's see how this one goes. So let's use find zero sum, right? I know it's not find zero sum anymore, it's find pair sum. Okay, they can twist it, like they can say like find sum. Okay, so it's up to you. You just have to think actively, like how you can frame that according to the questions which you have practiced. Okay, so let's run it. So we don't have any such pair right now, that's why we are getting empty array. Okay, let me hit enter so you can see clearly. Okay, so now I'll use another array. This one, this knife function was giving us like -4 plus 2, right? So let's use the same for the find zero sum. As you can see, our find zero sum also started behaving the same way as we want it to. Okay, so this is all the presence of mind. Okay, and you will get good at this if you practice more similar questions. Okay, so all you need to do is, all I want you guys to do is, you just pick one pattern. You practice at least 10 to 12 questions of it, not more than that, maximum 10 questions. Okay, and then you can solve any question related to that pattern. Okay, related to that pattern, not any question, right? Like, you can't jump into the graph questions, right, by just knowing the, like, this multiple pointers patterns. That's not practical at all. Okay, so if you encounter any question which is related to that particular pattern, then you can solve it quickly. Okay, so I have shown you like two different things. At the end it is the same thing, but the second one was a little bit twisted. Okay, so in interview they basically frame it a little bit differently. So they want to just check whether the developer is able to understand this problem statement now or not, because this is something related to which he might have practiced already. Okay, so they just twist the problem statement, and it's up to you whether you can identify, like, oh, it is the same thing but just with some twisted values. Okay, so yeah, this is it about the, like, multiple pointers pattern, or the, we can say, two pointers pattern. So in the next video we are going to practice one or two questions. Let's see, it depends. Like, we'll at least solve one question related to this multiple pointers pattern in the next video. Okay, so I'll drop this in the description, this code in the description, so you guys can refer if you want. Okay, so yeah, this is it for this lecture, guys. See you in the next one.